This is for concave mirror. The exercise was given for the concave mirror. But the last exercise I did online. That's fine. Yeah, but I don't think I have given any solution for that. I was waiting for a solution for but this was a mirror exercise. The previous one. Okay, the previous one. There were 5 constructions. So I have asked you to submit it. I don't have many responses. Some of you have done it. It's not graded, but it's a good training. Yes, question? No, I can't. Sorry, I just can't see anything. Now you work for convex mirror. Yeah, okay. Because of the algebraic value, it will be the same formula for a convex mirror. Except that for a convex mirror, C is on the other side, okay? Because the convex mirror is that way, okay? Instead of this. So we are doing that one, okay? So the first question was, you got there's no ruler. No ruler. Okay. So it also works with linear. No. Bien sûr, il faut que je vous dise, cette oreille n'entend rien du tout. J'entends absolument rien. Vas-y. Ça marche aussi pour un miroir blanc. Si on met SC à l'infini. So I'm not going to answer. I'm just going to give a solution for 2 mirrors. Okay. For the plane mirror, we have talked about it in class. Okay. It's the same thing as having what? For a plane mirror, what is happening when it's plane? Where is C? At infinity. We talked about that. Plane mirror is different. To find an image with a plane mirror, you just find the symmetric. Okay? So I want to show you the construction for the first example. This one was simple. It was F, C, and A was between S and F, the middle of Fs. Okay? So here I have SA equal SF over 2. Plug this into that, and you get SA prime equal minus SA. Just have to plug this into the equation. Solve for it. It's easy. Almost everybody did it properly. Okay? So now you need to know how to do the construction measurements. Okay? So you draw AB. And the rule is, you know the rule with the 3 rays, the one parallel to the principal axis, the one coming to the focal point, and the one through C. Okay, so you know that. But you need to draw the real ray is solid line, and virtual rays with dot line. Dot line for virtual and solid line for real. Okay? Same thing for image and object. When an object is virtual, you need to draw it that way. And when it's real, use solid line. Okay? So Georgia did it well, but that point has to be repaired. Okay, so I want to draw that for everybody. I'm gonna draw on two ways. Two are enough. Okay, to get 1 point. Two are enough. So this one, okay, to B and C, which is the mirror, in such a way that there is no deviation. So it comes back that way. Okay. Use 1 arrow for one ray, and then I'm going to draw a second arrow. So which one? This one, for example, the one coming through B and F. Okay. So for this one, I'm going to use 2. So, okay. Non, pardon. Parce que j'ai fait une faute sur mon papier, ça me... Goes through F, so comes back parallel to the parallel axis. Okay? So now where is B prime? To get B prime, you see where do they cross? Cross there, okay.
Where's the prime on the B? Above A.
About A?
Above A. Where's the B above A? Prime.
Sorry, B. The B.
Okay.
And so you got B prime there. Okay? So those are real weights. Everything here is virtual. Okay, use that line for that. I'm going to send the solution. This one is false. Okay, because we're not going to do sign on that. You need to practice. Just want to do the last one. 5. Because this one had a virtual object. Remember, it's possible to have a virtual object. You could create it with an optical system. And then, well, use a way through a mirror, okay, to get an image. That's one. So I said, I think they were F, C, okay. And so A was SA was SF over 2, I think, minus SF over 2. Okay. So if you plug this into the mirror equation, you get 1 equals SF over 3. So your image is somewhere there. Okay. Question?
So it would be 2SA equals minus SF if you rearrange the equation.
There is 2 SA
Equals minus SF. Because SA equals minus SF over 2.
minus SF.
Yes. Yes.
So you
Is it over 2 or divided by 2?
2 divided by 2.
2, okay.
Okay. So you plug this into the equation, you get this. Okay. So how to draw it? So first of all, this object is virtual because it's on the other side of the mirror. So I will draw it that way. Okay. That line. So it's going to be the same for diopter. It's easy with mirror because we know that everybody here is virtual. For diopter, it's different. It's going to be virtual if it's not where the rays are crossing each other.
Okay.
I mean, it's going to be virtual if the rays are virtual. Okay, so I do exactly the same. Okay, so this way there is a ray coming through B. Which part of the ray could exist there? Which part of the ray is real? And the one which is created this image is real. Everything here could be real.
Yes.
Could be real rays coming from another optical system. Okay, and it's reaching the mirror. Okay, in such a way that the deviation goes to F. Okay. I've got one. Let's have the second one. The one coming through F, maybe. That would be or C. C'est difficile sans. Okay. This one is real. There is no deviation, so it comes back here. So now where is B prime? It's going to be there. So it's my drawing is wrong, okay, because I should find the solution. It's difficult to do it on the board, okay? So you should have it somewhere here. It should be cross somewhere here, okay? And it is real. It is real. Okay? So I will send you the solution for the exercise. Okay?
Yes,
Yes.
yeah, yes, perfect. Good.
What else did you have to do for today? Question, you have many questions, right? Have you tried to do something or? So you see on the recueil de construction. So it's French, that's the same for everybody. So I want you to have the same, okay, because on the day of the test you have the same test. You have further construction to do. I will send the solution for the mirror. You have to do that on your own. Maybe the solution will be on the Moodle. Okay.
Lenses.
I can't remember. I think last time was terrible. It was a terrible time. I want to make sure you had the kind of lecture about the diopter and the formulas. Do you have the document with the formula on diopter? I think so, right? Otherwise, I need to review that.
Uniform doesn't have the diopter for the ones in the activity. So you haven't given us anything different. We just asked the activity about diopter. Not the document with the formulas and everything.
Not the document with the formula and everything?
Yeah, I don't think we have it. What does it look like? It's
I'm
talking about.
show you what I'm talking about. So I'm not sure you should have a document like that because everything is on document.
Oh, well, you were just saying you were just wondering if you gave it to us. You were just wondering if you gave it to us.
I wonder myself.
Yes.
No.
I think they have
No,
a
it's
different
elected,
buttons.
it's elected with the button, with the arrows on the side here.
I'm glad to.
Oh, nice.
What did you say?
Yeah.
Oh, M.
Oui,
M.
Con. That's a few cheese. Yeah.
Oh,
That's
Oh.
all.
yes, I know.
Okay.
No. It's not a movie.
So I kind of remember that last time we were able to find the position of
Yeah, sure.
the image when the object is at infinity and the position of the location of the image. So the location of the image when the object is at infinity and the contrary, right? We did that last time.
Yes.
Have you seen that?
Yes, you show it.
Okay. So I must have. I sent that to you, right?
Yes, I think so. It's really
Okay.
small.
So you need to understand most of it. Merci. Merci. Thank you.
One check.
Oh.
I did not sign up for this.
Ouais,
One more point.
ouais, c'est un peu trop.
Oh, nice. Thank you, Pastor.
So, what is a spherical refractive interface? First of all, we had a physical description. I think everybody understood, right? And I asked you how many diopters do we have in the lens, and you told me two interfaces, so 2 diopters in one lens. Okay. Then we know that it uses Snell-Descartes law. Okay. Which is derived from the Fermat principle of Fermat, principle of this time. We have seen all of this, okay? So you need to read that just to review everything we've seen before. Okay. Maybe we should read a little bit of that one, okay? Thomson in air looks at Thomson in water. The light propagates from Thomson to Thomson on ice. Okay? So we have seen that if Thomson sees an image, that is because the rays forming this image, it should be in dot line, right? No, actually no, they are real. They are going through through the water. Okay, so he is able to see the light going through the diopter, right? So why do you remember when we did the optic cube?
Mm-hmm.
There were questions saying why is the image greater than the stick, right? Yes.
Because the calculation of the refraction, the image is constructed closer. So it's
Exactly.
bigger. And that there is the
From
opposite.
the eyes.
It's constructed further away.
Okay, so even though the size is the same, we see it bigger because the eye is just closer. And we talked about apparent number. So all of this has been seen. You need to read it carefully, and it's gonna be all right. And then you have some construction, okay. But I know I have. I know I told you already that it's non-stigmatism. We talked about that last time. We did that, right? Okay, so we did that. We did this. I'm sure about that. I remember. So all of this is done. The only thing that we haven't done properly is the last part, which is the construction. I haven't done the construction part. Okay, we saw the analytical study. So here, what is given in the leeway is the same thing as this, except that IMA is for image, OBG is for object. So in your library you got N over SA prime minus N prime over SA, or the N prime over SA prime minus N over SA. Okay, equal N emergent minus N incident over SC. That's the same equation. Okay. From this equation, how do you get the one for the mirror? Would you be able to get the equation, the mirror equation, from this one? Yes.
Yes, because we have N emergent and N incident are the same, and so we can put an
So
equivalent
they're the
factor.
same, exactly. We're on the same medium. N on 1 and why do we don't get 0 here? So I agree with that. You get N. Let's try to use this for a mirror, okay? Is a mirror like a diopter? It's kind of the same, except that we are in the same medium, okay? And here I have, instead of N minus N, I'm going to put it that way, okay?
And then you have a plus because it's reflecting instead of refracting.
Yeah, because light is reversed, okay? So in this direction, and then in the other direction. So we have to change all the sign here. But SA is still taken, positive in this direction. So you need to this and change this. And so you get the mirror equation. Okay? So we should have started with this actually. So what about the transverse magnification? So if you have these two. You have to construct an image with a diopter and work on the transverse magnification. Okay. If you haven't done that, we're going to do that now.
The transverse magnification, is it just the amplification of the image or the reduction of the image?
Yeah, the transverse magnification, the definition of that is always the same. It's B prime over AB. That's the definition. So,
I don't understand why, if the ray is outside of the diopter, if the object is outside of the diopter, then
outside of the diopter, I don't understand this.
okay.
Oh, you mean the diopter
Yes.
is the whole thing, right? It's when you change from one medium to
okay.
another one. So I don't understand outside of it. I don't.
Okay, no,
What does that mean?
no, that does
Just
make sense.
reformulate.
No.
Okay. It's in one medium or another one. So for the plane refracting surface, we have done that already. So switching to the rest. And so you got construction here. Example. I'll come back here. Alright. So here you have the formula, okay, that you must use, the verification, and the result for a plane refractive surface. Excuse me. Again. And the graphical study part. Okay. So to find, first of all, to find f and f prime, you need to plug infinity into the equation. I like to use the same notation as in your entry. We have n minus n prime, right? N prime minus n. So to find f, you just need to have a prime and a as at infinity, and you get f and f prime. Okay, that's how you do it. So we see that for a thin spherical refracting surface, thin spherical means paraxial approximation. It means that we are just taking a very small part of the sphere. Okay? If it is that way, I'm going to just take this part. Okay? Meaning we are in the Gauss approximation, using approximation of Gauss. So you have some examples of construction. Hopefully you have them on the document I sent to you. You need to be able to draw some construction. Okay. The same way as what we did for the mirror. So here it's complicated because look at f and f prime. Okay, the location of f and f prime depends on n and n prime. It's not symmetric, okay, because we have different medium. Light propagation is different on one side and on the other. Okay, you still have an example. Yep, here, for example, this one. So I know you will be able to do that by yourself, but if you have some example, it's great. So here, what about AB? What about the object on this situation? It is virtual. So the red and blue solid lines are real rays, but they are crossing. Sorry. I mean, D is not existing. This one is virtual. Because when the ray goes through that surface, okay, they're gonna be going in another direction. the image is where the ray cross each other. And if it cross in a different medium than the one where the rays are existing for real, it is virtual. Okay. Is it clear for you, all those constructions? So you just need to, to be able to find f and prime using the
rays
equation.
that are, so the ray that is, no, sorry, I think I answered my question looking at the thing, so fine, sorry, thank you.
Okay. So can we try to do the APP with the eye? Try to do it. You just need the equation and try to answer the question by yourself. We are in group. It's an APP. You should be able to work with your group. Okay. So let's just try to do the. I'm sorry, I cannot print this, right? I'm just going to send that on the Moodle. It's already on the Moodle. It's on the Moodle. And you got some more exercise. We won't be able to do them in class. I can allow 20 minutes to answer question next time about the exercise, but I will give you the correction and you will try to do it. Okay? So all of this is already on the Moodle.
When is next time?
Next time is Friday.
And where?
Here. Okay. I think so. Unless I have
Are you agreeing with me, Nathan, or with the question? Thank you for agreeing with me. It's more sense that I'm insecure and I want to see how this is all.
Okay, so C is supposed to be.
Work time.
about the eye, what you need to do. So just for the eye, can we just answer the first part of the question? In this model of the eye, what is the accommodation? What is changing? What could be, yes, variable?
On the picture, we see that there's a radius for the second part.
The radius is variable. Yes.
Yes.
Okay. We're gonna assume that the distance between S and the retina is 2 centimeters. It's fixed. It's always the same. I hope you're not OCD because this is gonna stay. You can try it.
So we can switch up the light on the black.
So what does accommodation do? Accommodation is a change of the radius. Exactly. Here in this model, is accommodation. So can you try to work out the construction for the two distances, 25 centimeter and infinity for the object? Okay. Is that which is it asked actually? Question 1 of accommodation of the eye. And compute SC, SF, SF prime in both cases. We haven't done right question 2 and 1. You need to be able to do that for one construction by yourself. Anyway, you will have to do all of them. We're not doing that. We are doing it all. We are doing it this part right now. This part. Yes. Yeah, I have it by yourself. By yourself, I think so. No. I'm sure you will be able to.
Relax, why are you going so fast?
And
Draw on your paper. That's nothing. Don't draw like that.
For the retrospective on the optic cube is going to be an exercise. So you don't do the retrospective on the optic cube, you do that as an exercise. That's the most important part of the Let's do the accommodation of success.
How do you see your English is better than mine? He speaks exactly.
So this is just what is asked here is just one construction. Okay, and work out this formula. But I gave a document.
What is he doing? No, that's okay.
Will you be able to see
SA prime will be n prime. This thing is 0.
Well, we assume that it's water in the eye. Sorry. Okay.
Fine, sorry.
This is sensible.
Forgive me.
Well, we have to Should be easy.
Can you give me that lighter? Oh, this my dick. Which one are you on, Nathan? PP. You're on PP.
Number 2. What is
Where's my stop stealing my stuff?
So I think
We asked you to compute.
I never did that.
And again, before.
Yes, in another world. You know what he meant? I saw it in that. Yeah, like
I said we assume we have water in the size, and that the distance between the retina are already 16. This is not going to move, okay? It's fixed.
Yeah, let's see.
Because this is ready.
Madame, c'est 25 ou moins 25?
Thank you for being there.
Yes, I am there.
I'm not supposed to grade you, but I wish I could have
Yes, I'm done with that.
some submission of the construction. Because I cannot help you if I don't see your mistake. The construction, the one that I gave to you yesterday. I'm not offering some more work for me.
So we have to reach a.
There's a problem. If you use the formula, find f of 1 this time for the construction of the diagram. You need to find f prime and then draw your image using the definition of f and f prime, right? Of course. Exactly like for the mirror. Same thing.
What are you watching me?
I will send this
Stop. No, but what's this? Oh. I don't want to do work.
Yeah.
I already did that.
You've done the work.
Okay, how where?
Number 3.
You know what? Instead of submitting, can you
And by the way,
do that for Friday?
The special operation. The operation. Is able to accommodate the image of a lot. And it's from more quantum relative. As short as the image. That's far from yours.
Yeah, mine is way. 25, that's big.
I would, if I were you, I would spend 80% of my time on reading the document and 20% on doing the construction. But 80% of the time reading the documents.
It's bigger. This is bigger for sure. No.
Yeah, so it's smaller.
What is here? What is variable in the formula? This one is variable. This one could change. Okay? That's what it means. When change of R means just a
Not that lucky. No, it's not.
So this is.
Honestly, the right thing.
Yes.
His friend, my friend, is double.
No.
No shit. What the fuck? You're a 19-year-old.
I'll wait for my results. You shouldn't bring up something that is very
I don't see why
no, no, no.
Yeah, I mean, oh no. What do you think I have that?
His jacket is brown. His hair is most of his.
It's like brown. This is. Hi, my friend. Good to
Hi.
see you to work now.
Oh, I'm really glad. Oh, I hope it's
Yes,
I just hoping like what do you guys inspiration? Yeah, that's it.
I know, that's all.
I think, but I did to one thing.
No deal, like, you've done this. Exactly.
But I got full of the first exam. I never really went over this. Yeah, 18 and a half or 20. I didn't bring anything with me. I don't know if they were. Oh no, I don't know that. I have this.
Is this what the exam is? What's the exam?
The first one? Yeah. Was really fucking hard. They had a. Oh. It was like really bad. They had really bad translations. So bad that I read the question. That's not bad. They gave both even they knew they and yeah, I remember I don't do the answers.
But then they have.
I don't think You can definitely get away. You need it.
Tristan
Where's it going?
broke my bottle.
It did?
When he took my bag to get off, he like threw it on the floor and my bottle broke.
Yeah, we're a
I'm so sorry.
It's fine, it doesn't come out of the water, it's fine.
What does he got?
Yes, because I need to make it feel bad. It's
It's
fine. It's a style now.
Yeah, it is.
I like it.
That looks sick.
Yeah.
You should do some more.
It looks nicer now.
Oh,
Yeah, you need to
I
be
like
doing
it.
Say it's like 1 million and he needs to buy you.
Yes, this was very expensive to me.
I think
Tristan, my dead
I'll stop it
grandma
now.
bought me this.